We're given that x is a good approximation of sine of x near 0. We want to use a tangent line approximation at 0 to show that it is a good estimate. So for a tangent line, we want a point and a slope. Our function here is sine of x. So for the point, we're looking at 0. It means x is 0. The y value is when we plug in x equals 0 and for sine. So sine of 0 is 0. The slope is the derivative. The derivative of sine is cosine. And we're interested at x equals 0, so we're going to plug in 0 in for x to get cosine of 0, which is 1. So this is what this looks like is a y-intercept of 0, slope 1. Clearly, that is y equals x. Okay, so as we can see, x is that tangent line. So near 0, y equals x is a very good approximation for sine of x. And we just verified that. Now we want to see how much error is there in this approximation at x equals pi over 6. So for that, we're going to look at delta y over y. Here delta y is the absolute error. And then y is the actual value. So for the absolute error, we're going to take our estimated amount and subtract it with the actual amount. Okay, so for us, we're going to use a tangent line to estimate it. So if y equals x, at pi over 6, when x is pi over 6, y is also pi over 6. And the actual value is sine of pi over 6, since sine is our function. And then we're going to divide that by sine of pi over 6. We know that sine of pi over 6 is 1/2. So we get pi over 6 minus 1/2 all over 1/2. And if we simplify this, we get 0.0472. And this is the relative error. And if we want to get the percentage error, we're just going to multiply the relative error by 100 to get 4.72%. So there's 3 different types of errors for this problem.